Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you are doing well. Dear students, welcome back in TIST Virtual Learning System in the first spell of final term. Dear students, this lecture is for grade 8, subject chemistry. And in this lecture, we will discuss chapter number 3, which is about periodic table and periodicity of properties. This is my 18th lecture, and I am your lecturer, Mrs. Saira Jamal. Major concepts of this chapter are periodic table and periodic properties. Let us discuss the first topic, periodic table. What is periodic table? A table showing systematic arrangement of elements is called periodic table. A table which show the arrangement of systematic arrangement of, like the elements are arranged in a proper system or it follow a proper system. So that systematic arrangement of elements is called periodic table. There are many periodic tables and are presented by many scientists, but the periodic table which we are using until now, that is called modern periodic table or long form of periodic table, and is presented by Moseley in 1913. This long form of periodic table is based on periodic law. What is periodic law? It states that if elements are arranged in the order of increasing atomic number, then their properties are repeated in periodic manner. Periodic law states that all the elements which are arranged in the periodic table, they are on the basis of their increasing atomic number. Means all the elements in the periodic table are arranged on the basis of their atomic number, and the sequence is starting from the low atomic number towards the higher atomic number or greater atomic number. So all the elements are arranged in this order and their properties are repeated. Means like after reaching to group 8 elements, the next element is arranged in group number 1. The reason is that the properties of that element is repeated. That's why it is assigned the same position in group number 1, because the properties of that element is same like the elements of group number 1. So all the properties of the elements, if they are repeated, so they are assigned same position in the periodic table. This is called periodic law. Now, classification of elements in modern periodic table. The elements are classified into group and period. What are periods? Horizontal rows of the periodic table are called periods. There are 7 periods in the periodic table. The first 3 periods are called short periods and the remaining periods are called long periods. The properties of elements within a period changes gradually as you move from left to right. When we move from left to right in a periodic table, the properties within a period gradually changes. Definitely atomic number changes, so the properties will also changes. But when you move from one period to the next, the pattern of properties within a period repeats. This is according to the periodic law. As I told you that the properties of the elements which are present in the same period, like when you move from left to right, the properties are changes gradually, but in the next period, which again start from group number 1, the properties are repeated, which is according to the periodic law as I told you. Now, number of elements in the periods of the periodic table. The first period of the periodic table is composed of 2 elements. second period 8 element, third period 8 element. So the first three period, first, second and third, they are called short periods, while the fourth, fifth, sixth and seventh periods are called long periods. And fourth, fifth periods are composed of 18 elements. Sixth period is composed of 32 elements. Seventh period is incomplete and it contains 23 elements. Groups. The vertical column of elements in the periodic table are called groups or family. The vertical columns in a periodic table are called groups or family. Elements with similar valence shell electronic configuration are placed in the same group. Elements which have same valence shell electronic configuration, valence shell mean outermost shell. The outermost shell configuration is same and those elements are assigned same position in the periodic table. There are total, how many groups are in the periodic table? There are total 16 groups in the periodic table, which are further divided into A and B groups. Out of 16, 8 groups are called group A elements and 8 groups are called B group elements. Each group is identified by a number and the letter A or B. Like if it is group number 1, 1A, 2A, or 1B, 2B. So each group is identified by a number and the letter A or B. A group elements are called normal elements, typical elements, or representative elements. There are three names for group A elements. They are called normal elements, typical elements, or representative elements. They are also called main group elements. Main group elements, normal, typical, representative elements. B group elements are called transition elements. Some groups of elements in the periodic table have been given specific names. Like group 1A elements are called alkali metals. Why are they called alkali metals? Because their oxides or hydroxides form alkaline solution when react with water. When group number 1A elements, their oxides or their hydroxide, when they react with water, they form water. That's why they are called alkali metals. Group 2A elements are called alkaline earth metals because their oxides or hydroxide form alkaline solution when react with water. Their oxides are abundantly present on earth crust. That's why they are also called alkaline earth metal. Alkaline due to the property that their oxides or hydroxide from alkaline solution, same like alkali metals, but they are also called earth metals. Why are they called earth metals? Because their oxides are abundantly present on earth crust, or their oxides are present in large amount on earth crust. Group 7A elements are called halogens. Halous means salt and gens mean former. So halogen actually they react with metals and form salt. That's why they are called salt former means halogens. While group 8A elements are called zero group, noble or inert gases. Why are they called zero group, noble or inert gases? Because they do not react readily with other substances, or they do not readily undergo chemical reaction. Why they do not readily undergo chemical reaction? Because their outermost shell completely filled, so they don't need to react with other substances. So as they do not really undergo chemical reaction because they are highly stable, their outermost shells are already completely filled. So that's why they do not undergo chemical reaction and are called noble or inert gases, and zero group because their valency does not change. Their valency remains same. Their valency remains zero. That's why they're called zero group elements. You can see in this image a periodic table, modern form of periodic table, which is also called long form of periodic table, presented by Moseley in 1913. And this is the modern periodic table and still in use. You can see in this image, there are the vertical rows. These are called vertical rows. The vertical rows, like from top to bottom are called vertical rows. The vertical rows present in the periodic table are called groups. All these vertical rows are called groups. How many groups are there in the periodic table? You can see we have total, like according to the numbers, if we see there are, they mention 18 groups in the periodic table, but these vertical columns as these are 18, but the group numbers are not 18. Actually, the group total groups in the periodic table, they are 16. There are 16 groups in the periodic table, although the vertical columns are 18, but the reason is that I will show you in next slide that the B group elements, one of the group is further classified into three subgroups. So that's why the last three digits are for that group, like you can say it 8B. So total we have 18 groups, and out of those 18 groups, I told you this is 1, 2, group number 1, group number 2, group number 13, 14, 15, 16, 17, 18. They are called A group elements. They are called normal elements, typical elements, representative elements. So main group elements, group number 1, 2, then 13, 14, 15, 16, 17, 18. We also call them group 1A, 2A, then 3A, 4A, 5A, 6A, 7A, and 8A. These are called A group elements, and their numbers are 8. The remaining groups which are here, these are called the B group elements, and the B group elements are also, they are like 8. So as I told you that you can say 1, 2, 3, 4, 5, 6, 7, 8. 8 are the, I told you, are the transition elements or B group elements, but this group is further classified into, you can say, 2 more subgroups. So total there are 3 groups, but these 3 columns or these 3 vertical columns are assigned same name, that is 8B group, like they are called B group elements. Okay. So these are called the B group elements, which are also called transition elements, while group 1A, 2A, then 3A, 4A, 5A, 6A, 7A, and 8A, they are called main group element, typical elements, representative elements. And these are called B group elements. Also the 2 groups which are down, which are assigned separate position in the periodic table, they are also, we can call them the inner, they are called inner transition elements, and the upper one are called outer transition elements. They are also transition elements, but transition elements are further classified into 2 series or into 2 categories. These one are called the outer transition element, and those transition elements which are assigned separate position in the periodic table, they are called inner transition element. Inner transition elements are further classified into 2 series, lanthanide series and actinide series. Lanthanide series and actinide series. Lanthanide and actinide, they are given the names because of their first element, this lanthanum, La, lanthanum. Because of this lanthanum, because you can see 57 atomic number, after 57 is 58, then 59, so on, 71. After 71, 72 is here. So all these are the transition element, but those which are over here, they are called outer transition elements, and the lower one are called the inner transition element. And this series, which are also the inner transition element, they are called actinides. Why are they called actinides? Because their first element is actinium. You can see 89, actinium is the first element. After 89 is 90, 91, and so on. 103, then 104 is here. So as I told you, that all the elements in the periodic table are arranged on the basis of their atomic number. So we can see that hydrogen has atomic number 1, helium has atomic number 2. Then one more important thing, that the properties of the elements are repeated in a periodic manner, that is periodic law. So the atomic number 3 elements, its property are same like the hydrogen, which is the atomic number 1 element. So you can see atomic number 11 element, 19 element, they have, all of them have same electronic configuration and that they have same properties. So the reason is that as the properties are repeated in a periodic manner, that's why the next element after 2, which is 3, it comes again in group number 1. Then after neon, sodium 11 is again present in group number 1. So the properties are repeated in a periodic manner. That's why the next element after these, they are assigned the position in group number 1, because their properties are repeated. The specific name for group number 1A element, 1A elements are called alkali metals, except hydrogen, because hydrogen is a gas. So the rest of all are called alkali metals. Why are they called alkali metals? I told you, because they are oxide. Oxide means reaction of lithium and oxygen will form LiO, Li2O, which is called lithium oxide, sodium oxide, potassium oxide, rubidium oxide, cesium oxide, francium oxide. So they are oxides. When we dissolve them in water, they form basic solution or alkaline solution. So that's why they are called alkali metals. Group 2A elements also have a specific name. They are called alkaline earth metals. What are they called? Alkaline earth metal. Alkaline, I told you the reason is same like their oxides or hydroxides, same like alkali metals when dissolved in water form hydroxides. That's why they are called alkaline. But why earth metals? Because their oxides are abundantly, or their oxides are present in large amount on earth crust. That's why they're also called alkaline earth metals. Then the group number 7, they also have a specific name, halogens. They are called halogens, the green color halogens, the white color noble gases, noble gases. All the purple one are called transition metals, transition metals. And the light pink color are called other metals, means they are called metalloids, because their properties are some of the properties they resemble metals, and some of the properties they resemble they resemble the non-metal. That's why they are called transition. Transition means in between. Metalloids means the properties are in between metals and non-metals. Then other non-metals. These are the non-metals. And halogens, noble gases, this light green color like lanthanides. Lanthanides are also called rare earth elements because they are rarely present on earth. And the last one are called actinide. Why are they called actinide? Because I told you lanthanide and actinide because of their first element, which are lanthanum or actinium. So these group of the periodic table, we can also recognize them from their first element. So like you can say that group number 5 is also called boron family because the first element is boron. Of group number 3 is boron. So we can also call it boron family. Group number 4 is also called carbon family. Then nitrogen family. Group number 6 oxygen family. Group number 7 fluorine family. Like the first element can also decide the family of the periodic table. But that classification we rarely use. We have self-assessment exercise 3.1 in which period and group the following elements are present. The first one is magnesium. Atomic number of magnesium is 12. Mass number is 24. First of all, we have to write the electronic configuration according to the Aufbau principle. 1s2, 2s2, 2p6, 3s2. Total electrons are 6 plus 2, 8. 8 plus 2, 10 and 10 plus 2, 12. So you can see 1 as 1, shell number is 1, shell number 2 means L shell and shell number 3 means M shell. So we have to see the valence shell. Valence shell means the outermost shell. The outermost shell or valence shell configuration is 3s2. Now you know that the n value or the shell value tell us about the period number. So n value or shell number is 3. N is equal to 3. So magnesium is present in third period. And the number of electrons present in the valence shell, it tells us about the group number. So the number of electrons in the valence shell or the outermost shells are 2. So it must be present in group number 2A. B part, neon. Atomic number of neon is 10 and its mass number is 20. So electronic configuration is 1s2, 2s2, 2p6, 6 plus 2, 8, 8 plus 2, 10 electrons, and 1 means first shell, 2 means second shell. Valence shell is the second shell. Valence shell electronic configuration is 2s2, 2p6. The value of n is 2. So 2 means that the neon is present in second period. Since a total number of electrons in the valence shell are 8, 2 plus 6 equal to 8, it must be present in group 8A of the periodic table. C part, silicon. Atomic number of silicon is 14. Mass number 28. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. So 1 is shell number 1, which is also called K shell. 2, n is equal to 2, L shell. N is equal to 3, M shell, the third shell. The third shell is the outermost shell, and the configuration of this outermost shell is 3s2, 3p2. Again, the value of n is 3. So silicon is present in third period because I told you the value of n tell us about the period number. And the number of electrons which are present in the outermost shell tells about the group number. So how many total electrons are present in the valence shell? 2 plus 2 equal to 4. So it must be present in group 4A of the periodic table. Then D part is boron. Atomic number of boron is 5. Configuration 1s2, 2s2, 2p1, and the valence shell configuration or outermost shell configuration is 2s2, 2p1. What is the n value? N value in this case is again 2. So boron is present in second period. How many total electrons are present in this outermost shell? 2 plus 1 equal to 3. It must be present in group number 3A of the periodic table. Coming towards the example 3.1, identify the group and period of an element on the basis of electronic configuration. The pattern is same like the example which we done. The first element is aluminum. Aluminum atomic number 13. You have to write electronic configuration when it's 2, 2s2, 2p6, then this is the outermost shell electronic configuration. So the n value is 3 and total number of electrons are 2 plus 1 equal to 3. It means that aluminum must present in group 3a. B part is boron. Although I already explained, atomic number 5. Then 2s2 to p1 is the valence shell electronic configuration. N value is 2, so boron is present in second period. And total number of electrons are 2 plus 1 equal to 3. And I told you the number of electrons decide the group number, so group number is 3a. Second part is magnesium. Magnesium we already discussed. After magnesium, we have self-assessment exercise 3.2, in which period and group the following elements on the basis of electronic configuration are present. We have to decide in which group or period these elements are present. Same like the previous example and self-assessment. Sulfur atomic number is 16 and configuration 1s2, 2s2, 2p6, 3s2, 3p4. So outermost shell is 3, 3s2, 3p4, n is equal to 3, so third period, and electrons are 4 plus 2 equal to 6, so sulfur is present in group 6a of the periodic table. Fluorine, atomic number 9, configuration 1s2, 2s2, 2p5. Fluorine, and the value of n is 2. So fluorine is also present in second period and total number of electrons are 5 plus 2 equal to 7. So it must present in group 7A. Argon atomic number 18, 1s2, 2s2, 2p6, 3s2, 3p6. Valence shell configuration is 3s2, 3p6. This 2 is by mistake. So don't consider this 2. N value is 3 and it is present in the third period. Total number of electrons are 2 plus 6. I told you, don't consider this 2. 6. So 2 plus 6 equal to 8. It means that it must present in group number 8A of the periodic table. Example 3.2, classifying or dividing elements into group and period. The same thing. First of all, we have A, 1s2, 2s2, B, 1s2, 2s2, 2p3, 3. You can see that in these, in this case, A, B, and C case, the outermost shell is 2, 2s2, 2s2, 2p, 2s, 2p. So means the n value in all these three cases is n is equal to 2, which indicates that they are present in period number 2. Although the group numbers are different, but the period number is same. And the sum of valence electron are different, which indicates the group number. The remaining three, D, E, and F, you can see the outermost shell is 3, 3, 3, 3. It means the n value is 3, and all these elements are present in period number 3. While the sum of valence electron, I told you, indicate the group number, so we can arrange them in this table form, tabular form. Period number 2 elements, there are 3. A, B, C belongs to period number 2, and D, F, E, or D, E, F belongs to period number 3. Now, the number of valence electron decides the group number. How many electrons are present in this outermost shell? 2. So present in group 2A. How many electrons are present in this shell, subshell? 2. So group 2A. Because the group number decides, the valence electron decides the group number. So 2 electrons present in the outermost shell means that these atoms, these elements are present in group 2A of the periodic table. In this case, total number of electrons 3 plus 2, 5. So B is present in group number 5. Same here, 3 plus 2, total number of electrons are 5. So F is also present in group number 5. C, 5 plus 2 equal to 7. 7 electrons are present in the outermost shell. So it means that the element C belongs to group 7A of the periodic table. Same is for E, 5 plus 2 equal to 7. 7 electrons are present in the outermost shell, so E also belongs to group 7A of the periodic table. So, dear students, I hope you understand some important information about the periodic table. Inshallah, we will continue the remaining topics in our next lecture. Till then, take care. Allah Hafiz.